Today, I'll be talking about bonding. Bonding is important to chemical engineers. If we better understand the bonding between atoms, we can assess how bonds will be broken and new ones formed in a certain process, and in turn make the process itself more efficient. For example, to create water from oxygen and hydrogen, the molecular bonds first have to be broken before single hydrogen and oxygen molecules bond to form water, as you can see from the diagram. I will first talk about ionic bonding. I'm going to use sodium chloride as an example to explain how ionic bonding works. As seen from the diagram, Na has 1 electron in its outermost shell, while Cl has 7. If Na loses an electron, it will lose a shell and become smaller, but also a positively charged ion, which is called a cation. This electron then is transferred to the Cl atom, where it completes the outer shell of 8 electrons. In doing so, the Cl atom becomes bigger and is now a negatively charged ion called an anion. Now we have two oppositely charged ions which are held together by electrostatic attraction. This is called ionic bonding. An orbital is the space that an electron moves in. There are two types of orbitals that will help us better understand covalent bonding. Each orbital contains a maximum of 2 electrons. The s orbital is spherical, while the p orbital is dumbbell-shaped, but there are 3 p orbitals at right angles to each other, and therefore p orbitals can hold a maximum of 6 electrons. I will use ethene to describe covalent bonding. There are two types of covalent bonding, sigma and pi bonds. Sigma bond is formed when 2 s orbitals overlap, as you can see from the left diagram, and pi bonds are formed when 2 p orbitals overlap, as you can see from the right diagram.